Central tendency, lesson 4 under probability and statistics. So, what is a measure of central tendency? A measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within that set of data. As such measure of central tendency are measures of central location. They are also classified as summary statistics, the mean, or often called the average, is most likely the measure of central tendency that you are most familiar with, but there are others such as median in the mode. The median in mode are all valid measurements of central tendency, but other different conditions such as some measures of central tendency become more appropriate to use than others. We look at the mean, mode, and median and learn how to calculate them and under what conditions they are most appropriate to be used. So, mean arithmetic. So, the mean or average is the most popular and well-known measure of central tendency. It can be used with both discrete and continuous data. Although its use is most often with continuous data, the mean is equal of the sum of all values in the dataset divided by the number of values in the dataset. So, if we have n values in a dataset and they have values x sub 1, x sub 2, and so on and so forth up to x sub n, the sample mean usually denoted by x bar. Okay, so this will be the formula. So, as what we have here. Okay, then you may have noticed that the above formula refers to the simple mean. So, for this one, so why we called it a sample mean? This is because in statistics, sample and populations have very different meanings, and these differences are very important even if in the case of the mean, they are calculated in the same way. So to acknowledge that we are calculating the population mean and not the sample mean. So actually we use the Greek lowercase letter denoted as mu. Okay? So you have noticed that the above formula refers to a sample mean as I mentioned. Okay? The mean is essentially a model of your data set. So it is the value that is most common. So you will notice, however, that the mean is not often one of the actual values that you have observed in your data set. However, one of its important properties is that it minimizes errors in the prediction of one or any one value in your data set. That is, it is the value that produces the lowest amount of error from all other values in the data set. The most important property of the mean is that it includes every value in your data set as part of the calculation. So in addition, the mean is the only measure of central tendency where the sum of the deviations of each value from the mean is always 0. So before we're going to discuss what is the mean, what is the median, I just want to clarify when not to use the mean. The mean has one main disadvantage, of course. It is particularly susceptible to the influence of outliers. These are values that are unusual compared to the rest of the data set by being especially small or large in numerical value. So, for example, we consider the wages of the staff at a factory. For example, we have staff 1, 2, 3, 4, 5, 6, 7, and 9. For step number 1, that is 15,000, 2 is 18,000, 3 is 16,000, 4 is 14, 5 is 15, 6 is 15, 7 is 12, 8 is 17, then 9 is 90,000, and 10 is 95,000. The mean salary for this 10 staff is 30.7 thousand. However, inspecting the raw data suggests that this mean value may not be the best way to reflect the typical salary of a worker, as most workers have salaries is the 12,000 to 18,000 range. The mean is being skewed by the two larger salary or the large salaries. Therefore, in this situation, we would like to have a better measures of central tendency. As we will find out later, no, taking the median would be a better measure of central tendency in this situation. Another time when we usually prefer the median over the mean or mode is when our data is skewed. Of course, example, the frequency distribution of our data is skewed. If we consider the normal distribution, as this is the most frequently assessed in the statistics, when the data is perfectly normal, the mean, median, and mode are identical. Moreover, they all represent the most typical value in the data set. However, as the data becomes skewed, the mean loses its ability to provide the best central location of the data because the skewed data is dragging it away from the typical value. However, the median best retains these positions and is not as strongly influenced by the skewed values. And of course, the skewed distribution section must be discussed later, no? So, median. So, the median is the middle score for a set of data that has been arranged in order of magnitude. So, the median is less affected by outliers in skewed data. In order to calculate the median, so, I'll give you some example, no? So, based on the given, no, data. So, we first need to rearrange, no? We first need to rearrange that data into order or magnitude. So, small first. So, 14 is the smallest. 35 will be the next small. 35, 45, 55, 55, 56, 56, 65, 87, 89, and 92. So, right after we begin, of course, right after that, our median mark is the middle mark. In this case, as you can see here, 56, right? Highlighted in bold. It is the middle mark because there are 5 scores between it, 5 score before it, and 5 score after it. So, this work fine when you have an odd number of scores. So, because we have 11, right? Well, you simply have to take the middle 2 scores and average the result. So, if for example, if we have this one, so 65. So, again, rearrange, no? 65, that is 65, no? We start from the smallest again. So, 14, 35, 45, 55, 55, 56, 56, 87, and 89. So, this time, only now we have to take the 5th and 6th score in our data set and average them to get a median of 55.5. So, again, we have a 12. No? So, therefore, we consider the 1, 2, 3, 4, 5, and 5th and 6th position. Then we're going to add, divide by 2. So, therefore, we get the median of 55.5. So, how about the mode? The mode is the most frequent score in our data set. On histogram, it represents the highest bar in the bar chart of histogram. You can therefore sometimes consider the mode as being the most popular option. So, an example of mode is presented here. So, as you can see here, this will be the mode, the highest value. Normally, the mode is used for categorical data where we wish to know which is the most common category. As illustrated again, for example, this one, the mode is used for categorical data where we wish to know which is the most common category. As what we have here, no, we can see that the most common form of transport in this particular data set is the bus. No? So we have car here. So we have car here, train, tram, and of course the bus. No? However, one of the problems with the mode is that it is not unique, no? So it leaves us with problems when we have. Okay, so for this one, as what we have here, no? One of the problem with the mode is that it is not unique. So it leaves us with problems when we have two or more values that share the highest frequency. Because at what we have here, we have within the 20 and the 40th. Excuse. So we are now stuck as to which mode best describe the central tendency of the data. This is particularly problematic when we have continuous data because we have more likely not to have any one value that is more frequent than the other. So for example, considering measuring 30 peoples, okay, weight to the nearest, of course, how likely is it that we will find two or more people with exactly the same weight? The answer is probably very unlikely because many people might be close but with such a small sample. For example, for 30 people, in large range of people weights, you are unlikely to find two people with exactly the same weight. That is to the nearest 0.1 kilogram. This is why the mode is very rarely used when continuous data. Actually, another problem with the mode is that it will not provide us with a very good measure of central tendency when the most common mark is far away from the rest of the data in the data set. Okay, so for example, that's what we have here, no? In this diagram, the mode has a value of 2, no? We can clearly see, however, that the mode is not representative of the data, which is most likely concentrated around 20 to 30 value range. To use the mode to describe the central tendency of this data set would be misleading. So how about the skew distribution in the mean and median? So we often test whether our data is normally distributed because this is a common assumption underlying many statistical tests. So an example of a normally distributed set of data is given here in our diagram or figure. So when you have a normally distributed sample, you can legitimately use both the mean and median as your measure of central tendency. In fact, in any symmetrical distribution, the mean, median, and mode are equal. However, in this situation, the mean is widely preferred as the best measure of central tendency because it is the measure that includes all the values in the dataset for its calculation. And any change in any of the scores will affect the value of the mean. And this is not the case with the median or mode. However, when our data is skewed, for example, as with the right skewed data set, so as what we have here, no, based on the given median, no, is 8 and mean that is 10.1. We find that the mean is being dragged in the direct of the skew. In this situation, the median is generally considered to the best representative of the central location of the data. The more skewed the distribution, the greater the difference between the median and mean, and the greater emphasis should be placed on using the median as opposed to the mean. A classic example of the above right skewed distribution is income. So where higher earners provide a false representation of a typical income if expressed as a mean and not a median. If dealing with a normal distribution, in tests of the normality show that the data is non-normal. It is customary to use the median instead of the mean. However, this is more a rule of thumb than a strict guideline. Sometimes, researchers wish to report the mean of a skewed distribution if the median and mean are not appreciably different. For example, for a subjective assessment, and if it allows easier comparison to previous research to be made. Okay, the summary of when to use the mean, median, and mode. So, this will be the guidelines, no, that we will be able to use to know what the best measure of central tendency is with respect to the different types of variable. So for example, if your type of variable is nominal, best measure of central tendency is mode. For ordinal is median. Interval ratio but not skewed is mean. Internal and ratios but skewed, use median as your measure of central tendency. So measure of central tendency and group data. So there are three types of measure of central tendency, namely arithmetic mean, median, and mode. So mean and group data, the mean of data indicates how the data are distributed around the central part of the distribution. That is why the arithmetic numbers are also known as measure of central tendencies. So as what we have here, the mean of raw data. So the mean or arithmetic mean of n observation bar or variates, x sub 1, x sub 2, 3, and 4 up to x sub n is given by mean is equal to x sub 1, x sub 2, x sub 3 plus x sub 4 and so on and so forth over n. So in other words, mean is equal to sum of the variables divided by the total number of variables. So symbolically, so we have a sample for the mean. So, based on the given example, no, solve example on mean of ungrouped data or mean of the array data. So, for example, we have 5 no, student score. 80, 72, 50, 64, and 74 marks in 5 subjects in examination. Find the mean percentage of marks obtained by him. So, this will be the solution, no? Then, direct substitution over 5. So, if we're going to sum up the 5 value, that is 340 over 5. 340 divided 5, that is 68. Therefore, mean percentage of marks obtained by the student was 68% rather. So, this one is score of the following runs in 6 innings of a series. So, 45 to 78, 20, 116, 55. So, same as what we did a while ago. So, direct substitution. So, 45 plus 2 plus 7 plus 20 plus 116 plus 55. That is 316. Divide 6, that is 52.7. For example, number 3, find the mean of the first 6 whole numbers. Same as what we did a while ago. So, direct substitution again. Then add, divide 6, then 5 over 2. Of course, that is 2.5. Okay? For example, number 4, the mean of 6 variables or variates is 8. 5 of them are 8, 15, 0, 6, 11. Find the 6th variant. Okay, another way, another problem. So this will be the way on how we'll be able to solve this one. Okay, so for example number 3, find the mean of the first 6 whole numbers. So as what we have here, direct substitution again. Then add 15 over 6, 5 over 2, that is 2.5. Then for sample number 4, another way. For example, if the problem goes like this, no? The mean of 6 variates is 8. 5 of them are 8, 15, 0, 6, and 11. Find the 6th variate. So, let the 6th variate be an A, then by definition. So, as what we have here, okay, so direct substitution. This time, we have 40 plus A is equal to 6. According to the problem, 40 plus A over 6 is equal to 8. Because based on the given value, right, we have 8. So, therefore, 40 plus A is equal to 48. We transform A to the left side. That is A is equal to 48. Then 40 become negative. So, at the right side. So, 48 minus 40, this will become an operation. So, 48 minus 40 is 8. So, therefore, the 6th variate is 8. Now, the number 5 example, the mean length of ropes in 40 coils in 14 meters. So a new coil is added in which the length of the rope is 18 meters. So what is the mean length of the ropes now? So same as what we did a while ago. So same scenario, same formula. So therefore, we're going to get the 14.1 meter approximately. So how about the median of an ungrouped data? So the median is the midpoint of an array of numbers or observation. So let us denote the median by the symbol MD. If a set of data contains an odd number of observation, the median is the only middle observation that divides the set into two equal parts. So here we learn how to solve the different types of problems on median of ungrouped data. So based on the given example, again, arrange the variates in the ascending order. So we get this one. Okay? This will be the given value. Then right after arranging the variates, so this will be the results. Then the number of variates is 11, which is odd number. So therefore, we just simply count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So therefore, 1, 2, 3, 4, 5, 6, that is 160. So automatic. Or median is equal to 11 over 2, that is variate is 6, variate is 160. In example number 2, find the median of the first 5 odd integers. If the 6th odd integer is also included, find the difference of the medians in the two cases. So 1, 3, 5, and 7. So therefore, the number of variates is 5, which is odd. So choose the center, that is 5. Okay, if we consider the 6 integer, that is 1, 5, 1, 3, 5, 7, 9, 11. So therefore, we have even numbers, right? So now the number of variates is 6, which is even. So mean is equal to 6 over 2, and 6 over 2 plus 1 is a variate. So mean of third and fourth variates. Mean of 5 and 7 is equal to 5 plus 7 is over the 2. 5 plus 7 over 2 is equal to 6. Now, therefore, the difference of median is the two cases is 6 minus 5 is equal to 1. So example number 3, if the median of 17, 13, 10, 15, x happens to be the integer x, then find x. So this will be the procedures. Okay? Then x is an integer, so x is equal to 14. Because 13 less than x greater than 15, that is 14. For example number 4, marks the obtained by 20 students in a class test are given below. So based on the given example. So arranging the variates in ascending order. So we get variates equal to 20, which is even. So same as what we did a while ago. So 7 plus 7 over 2, that is 7 is the answer, no? So as what we have here. So how about the mode for ungrouped data? The most frequently occurring observation in the data set is called mode, also known as modal value. This is a measure of the tendency of the data value. So example, find the mode of 2, 5, 5, 8, and 9. So since we have 2, 5, so the most frequently occurring value is 5. So the mode is 5. So how to find a mode of a data? So mode of an ungrouped data is equal to the most frequent observation in the data. So data can consist of more than one mode. So a data distribution which one mode value is called unimodal, whereas distribution with more than one mode values is called multimodal. They can be bimodal, trimodal, and others. So based on the given number, example number 1, find the mode of the record of marks shown below. So state whether the distribution is unimodal, bimodal, or trimodal. So based on the given example, the mode is 8 and the data distribution is unimodal. So I have here an example at the bottom if you wanted to explore more about this example. Sample number 2. So, find the mode of the record of marks shown below. So, state whether the distribution is unimodal, bimodal, or trimodal. So, the modal value is 1, 3, and 4 because they are equal. And the data distribution is trimodal. So, we have an explanation here. So, ibig sabihin, 1, 3, and 4 appear 4 times. Therefore, 1, 3, 4 are modes of the given set of data. So, therefore, the modal values are 1, 3, 4, and the data distribution is trimodal. So, how about this one? A measure of central tendency for group data. So, we have a formula for mean, median, and mode. So, this time, we have an example here. Calculate mean, median, mode from the following group of data. So, we have a class here, no? 2 to 4, 4 to 6, 6 to 8, 8 to 10. So, as frequency, for example, how many occurrence? 2 to 4, that is 3, for example. For frequency of 4 to 6, 4, 6 to 8 is 2, and 8 to 10 is to 1. So, what we're going to do is to find the frequency, of course. We defined already the class and the frequency. So, what we're going to do is to get the mid value. So, 2 plus 4, that is 6, divide 2, that is 3. So, therefore, we have a mid value of 3. Actually, even without computation, we could able to find. So, at the middle of the 4 and 5, that is 6. Middle of 6 and 8 is 7. Middle of 8 and 10 is 9. Now, how will be able to get the f times x, no? So, 3 times 3, that is 9. 4 times 5, that is 20. 2 times 7, that is 14. 1 times 9 is 9. Now, for us to get the cumulative frequency, you just simply add, no? 3, that's retain 3. 4, this one, 3 plus 4 is equal to 7. 7 plus 2 is equal to 9. 9 plus 1 is equal to 10. Okay, so mean is equal to summation of fx over n. So fx is 52, right? Over 10. So therefore, that is 5.2, right? So to find the median class, so we have a computation here. And therefore, right after computation, based on the given formulas, direct substitution, and calculations, we get median is 5. For mode, the mode is 4.667 based on the given formula and a problem. So we define the lower boundary, frequency of the mode class, preceding class, succeeding class, and the mode class. So the mode based on the given values earlier is 4.667. So example number 2, calculate mean, median, mode from the following group of data. So this time we have 0, 1, 2, 3, 4 as our x or our variates. Then frequency is 1, 5, 10, 6, and 3. Then of course we're going to multiply to get the summation of fx. To get the fx, we multiply the f and x. So 0, 5, 20, 18, 12. To get the cumulative frequency, so 1, 1 plus 5, 6. 6 plus 10, that is 16. 16 plus 6, 22. 22 plus 3, that is 25. So the mean is 2.2. So median is 2. Okay, so this will be actually the process. Now, how about the fractals? In visual terms, a fractile is the point on the probability density curve, or the PDF, so that the area under the curve between the point in the origin is equal to a specified fraction. So for example, a fractile of 0.25 cuts off the bottom quarter of a sample and 0.5 cuts the sample in half. So the following image, no? So we give you a sample image for that. Okay, so based on the given, in a normal distribution, a fractile of 0.5 is equal to the mean. In other words, and the standard deviation. In other words, 50% of the distribution lies below the mean. So, a fractile for a p greater than 0.05 is called upper fractile. And fractile x sub p for p less than 0.5 is called a lower fractile. So, we have, of course, fractals are important in engineering scientific application in a different form of them. Percentiles are one of the first real-life exposure many of us to get statistics. So, quantiles, quartiles, deciles, and percentiles. The word quantile is sometimes used instead of the word fractile, and they can be expressed as quartiles, deciles, and percentiles. By expressing the decimal or fraction in terms of quarters, tenths, and hundreds, and respectively, and so on. So, this will be the calculation, and we have also the where v is the coefficient of variation of your variable x, and so on and so forth. So in order to find out, consult a table for a specific distribution you're working with. So the following table shows up the standardized random variable with a normal distribution. So calculating the fractals for variables when you do not know the underlying distribution can be tricky. So three methods are available: classic coverage method, prediction method, and a Bayesian approach. These advanced tools are usually used by engineers and can be found in the relevant international organization for standardization or publication. So again, the classical coverage method obtains values within a certain confidence interval rather than exact figure. So the prediction method, prediction limits are used as constraint to new values, while the Bayesian approach uses prior knowledge for distribution of random variables. So what is quartile? It is a statistical term that describes a division of observation into four defined intervals based on the values of the data and how they compare to the entire set of observation. So this will be the key takeaways. So how quartile works? Of course, we have divides data into 3 points: lower quartile, median, and upper quartile to form 4 groups of a data set. So we have a discussion here. So based on the given example, no, each quartile contains 25% of the total observation. So stated here. So example, suppose the distribution of math scores in a class of 90 students in ascending order. So first, mark down the median quartile 2, which is this case is the 10th value, that is 75. The quartile 3 is the middle value between Q2 and the highest score 8 is equal to 84. No, so Q3 is equal to 82 plus 84 divided 2, that is 83. Then Q1 tell us that 25% of the score are less than 68 and 75% of the class score are greater. So Q2, the median is the 50th, okay, 50th percentile, and shows the 50% of the score are less than 75. And 50% of the score are shown above, scores are above 75. And Q3, the 75 percentile reveals that 25% of the score are greater than 75% are less than 84. So what is decile? Decile is a quantitative method of splitting up a set of data into 10 equally large subsections. So a decile which has 10 categorical buckets may be contrasted with percentiles that have 100, quartiles that have 4, or quintiles that have 5. So this will be the takeaways for a decile. So how will be able to understand deciles? Of course, it is used to categorize large data set from the highest to lowest value or vice versa. So like the quartile and the percentile, a decile is a form of quantile that divides a set of observation into samples that are easier to analyze and measures. So a decile is usually used to assign decile ranks to a data set. A decile rank arranges the data in order from lowest to highest and is done on a scale of 1 to 10 where each successive number corresponds to each increase of 10 percentage points. So how to calculate a decile? So we have here, there is no one way of calculating a decile. However, it is important that you are consistent with whatever formula you decide to use to calculate a decile. So from this formula, it is given that fifth decile is the median since 5 opening close parenthesis n plus 1 divide 10 is the data point that represents the halfway point of the distribution. So decile are used in investment field to assess the performance of a portfolio or a group of mutual funds. So the decile rank acts as a comparative numbers of measures the performance of an asset against similar asset. So, of course, the government also used decile to determine the level of income inequality in the country. That is how income is distributed. So, we have an example actually here. And the table below shows the ungrouped scores out of 100 for 30 exam takers. Okay, so using this data, we have here the computations. So, value of 30 plus 1 divide 10 data. So, the result is the 55.2, that is the D1. And of course, for D3, no, we have 65.3 for this one. Then for D5, we have 77. So, half of the score lie above and below the distribution. How about the percentile? A test score in and of itself is usually difficult to interpret. So, as what we have here, we have an example of a percentile. So, if 65% of the score were below yours, then your score would be the 65th percentile. So, we have two simple definitions of percentile. There is no universal accepted definition of a percentile. Using the 65th percentile as an example, the 65th percentiles can be defined as the lowest score that is greater than 65% of the score. Okay, so actually a third way to compute percentile is a weighted average of the percentiles computed according to the first two definition. The third definition handles rounding more gracefully than the other two and has the advantage that it allows the median to be defined conveniently as the 50th percentile. So this will be the third definition. So we have here an example of the test score. So we have rank 1 to 8, then we give a number. So the first step is to compute the rank of the 25th percentile. This is done using the formula R is equal to P divide 100 times N plus 1. So applying the formula, we can get 2.25 as our 25th percentile. Then in this case, no, where P is desired percentile and N is the number of numbers, no, so therefore still we get 9.25. Then of course, for interpolate by multiplying the difference between the score by FR and add the result of the low score for this data, that is 5.5. Again, if we had used the first definitions, the 25th percentile would have been 7. If we had used the second, the 25th percentile would be 5. So we will compute the 25th and 85th percentile. For the 25th, we can get 0.25, and for 25th percentile, we can get 5. Right after the computations. Then of course, for the 85th percentile, so we can get the IR is equal to 2 and FR is equal to 0.5. So therefore, we can get 4 as our 85th percentile. Finally, consider the 50 percentiles of the numbers 2, 3, 5, 9, and 11. So, as what we have here, the 50th percentile is 5. So, I think that's it for today, and this will be our references. Thank you for attending our class, and good luck. See you next meeting. Once again, thank you very much, everyone. Mabuhay, and God bless.